Recording in.
Yeah, sorry. So I'm gonna, it's recording. All right, so as I was saying then, we're gonna be processing the data here. So the first thing we need is let's start with the simplest example that we can think of, which would probably be to download some data from the internet, right? So we want to think about that. So let's go ahead and create a script. All right, so let's do processing data. And let's just say, you know, get or download, well, let's say get text from URL, right? So from some kind of URL, we're going to get some data, right? So there's a lot of libraries that you can think for this, but let's, you know, there's several actually, and I'm only going to demo a few. I'll leave it to you guys to kind of, decide which ones you want to do. You can explore, as I said, Python has an abundance of these kinds of libraries. Okay, so let's do from URL lib import URL open. Okay, so let's try that one first. Let's just make sure that we don't need to install it or anything like that. Right, and it's available. Right, so this is basically the pipeline. So you need to download the text, right? So remember, my goal here is we're taking a very unstructured problem, right? And we need to convert it into something, as I said. So the basic pipeline would be, and remember this, some raw data, filter, clean it, apply the vector space model to it. Whenever I say, apply the vector space model, what I mean is convert the data into vectors that could be fed into a machine learning algorithm, okay? Remember, that means the X data, the features, and it means the Y data, the labels. That doesn't necessarily mean make it into a tensor yet, because a CSV file like iris and MNIST is already in the vector space model. Do you guys see that? It's already in that format, right? Converting it into a tensor just means that it'll work in PyTorch or TensorFlow. But MNIST, iris, as long as they have the column row format, they're already vector space model. Okay, does that make sense? All right, so good. So let's go ahead then, and just, here you'll come up with, so I'll do some examples and then I'll give it, as I usually do, some assignments. I'll probably just say, repeat this 5 times for URLs, repeat this 5 times for RSS feeds, repeat this 5 times for Twitter data. Remember that I did say, how many of you already got your Twitter data account? All right, just a couple of 3 of you. Remember, I set this at the very beginning of the semester. It takes a while, and I'll assign this homework today. Okay, so you need to get those accounts ASAP, because you're gonna need the Twitter API to connect to Twitter and download about. They only give you, they throttle it, so they only let you like 200 tweets per day, or of one day, and then 7 days. So really you only get like the last 7 days, like the last week, and 100 tweets every day, something like that. So you won't be able to get a lot, but at the same time, it's enough for us to do a couple of things. Okay, so you'll just repeat this exercise. Hopefully it'll be, well, we're also going to use count vectorizer. I know some of you have looked at it a little bit in previous assignments, so today we're going to take a look at that. Have a nice example. All right, so let's go ahead and go back to the script. And let's do URL. Okay, so now, let's just pick something. So I'm gonna I have something here. I like to grab things from Gutenberg, but actually we should probably be grabbing things from HTML pages themselves. All right, so I'm good, but I like to, grab things from Gutenberg just for fun. So let's see. If this is still the right path for them. And I'm grabbing just a book from the Gutenberg library. So let's see if we can find it. If not, we'll grab another URL. As you can see, it doesn't have to be, it can be any URL that you want. All right, perfect. So we were at, no error. Oh, well, actually, no, I didn't download it. Hold on. So I just created the URL. So now I need to grab it. So I'm going to say URL open. I'm going to specify the URL itself that we want to find on the internet, and then we're going to read it. Okay. So now it's the moment of truth. Let's see if it works. All right, that's a good sign, right? And so this is the pipeline basically of how you would obtain data, right? So what is this called? This is usually called scraping, data scraping, like scraping a shovel or whatever, but you do this on the internet. And this is a very common practice. In fact, you guys know that Google does something like this, right? What is that called? How does Google get all the URLs? Crawling, right? Or the crawlers, right? Spiders, I think, that kind of thing. So you can build one of those. We're not gonna, this is not an information retrieval class, so we're not gonna build a crawler, but this is the basic mechanism. You would download this, a website, and then what do? You look for all the links, right? You would look for all the links by the tags, and you create a list of them, and then you start scraping those URLs and get more links, and scrape those and get, and so on. And it's an endless cycle like that. But for our purposes, we're not building a crawler. So I have no goal here of creating a crawler. Instead, we just want to scrape data off the internet, and then we're going to start to use it, right? We're going to start to use it. So let's take a look at, so now I have it. So we can print out some things. Let's print out the length of raw. Okay. And as long as it's not 0, there's some data in there, right? In this case, we downloaded a type of a book, but it can be any kind of URL. So now let's go ahead and print out. We're going to treat raw as basically a list. We're going to slice it to about 75 characters, or letters. And then let's see what we have in here. So obviously we want to print this. Print. Okay, and so we have, so let's print a little bit more. Right, so you can see more data there. Let's actually just print the whole thing. How about that? Okay, so it printed. You see the entire website, right? Oh, okay. So actually, my link did not work, right? And what I got back is actually a page that's saying, sorry, we do not have this. You can see that there somewhere in here. Sorry, but your website does not have the page requested, or our website. Okay, so then that takes us into, we've got to change the URL. So let me see. Could be a couple of things. Could be that they only do encrypted HTTPS. I'm not sure. Those are things that you have to play with, right? As far as Gutenberg.org, obviously we reached it. Files 2554, 255. Yeah, they may have changed the things that they do. Yeah, I'm still getting the same thing. Let's try another one, right? So I'm going to try my own website, which I know it's pretty simple, static page. Let's see if I'm able to retrieve my own data. Okay. Try that one. And there it is, right? So it's got, information I have of my courses, etc. I can probably see the PyTorch class in here somewhere. Yeah, there it is. You see that? So I'm able now to, you can create, for instance, with a text file, you could create a text file of URLs, right? And then with that text file, then you can basically now download a whole bunch of websites. So now you have a way of getting data from the internet, scraping. Does this make sense? All right, perfect. So what are the problems that we have, or not necessarily problems, but what do we want to do? It depends on the type. It depends on the type of problem that we want to deal with, right? That's really what it comes down to now. So since we don't want a crawler, we don't really want the tags, right? We don't really want the HTML. If we were crawling, yes, we would want the tags so that we can basically start building our own database with links and all of that. Instead, what we want is, let's say, we just want text. Do you guys see that? All we want really here is basically text. So that means we need to find a way to filter out the URL tag so that we can end up just with raw text, hopefully. So that's one of the first things. So how do we deal with HTML? So there's a couple of ways. One way, there's two libraries out there actually. One is called Beautiful Soup, like soup, Beautiful Soup, and the other one is called NLTK. So let's, for this example, because we might end up installing a few libraries, let's go ahead and switch over to Bash and to Anaconda, okay? And we're going to go back to our environment, on the environment list. And then conda activate PyTorch UI 36. All right, so now we want to go ahead and what do we want to do? Conda install NLTK, right? See if it'll take that one. If not, we'll do a pip install NLTK. That should also work. Yes. And NLTK, as I said, is the library. It's called the Natural Language Toolkit, but it's got a lot of functionality in it, so that should be very handy. Beautiful Soup should also have a lot So let's try beautiful soup. Let's try pip install. I may just have the spelling wrong. Pip install. If you guys know it, know the command, let me know. Okay. Anyone know what the command is? Beautiful soup 4 with pip install or with let's try that. Was it all lowercase? All right. Yeah, good job. All right. So we seem to have it now. Okay. So great. So these are, as I said, I'm not even going to do a lot with these. There's a lot that you can do. This homework assignment can be very simple, but also endless, because in the sense that you're going to be filtering out lots of things. All right. I will only show, like, demo a few examples. You have to basically clean the data. That's really one of the difficult parts of, not difficult, but the main focus of this assignment is in the filtering. All right, so let's go ahead then. So we have a couple of these libraries. So now let's go back to my script, play with it a little bit. I'm gonna do ls, and then, all right. So now let's try and bring in NLTK in here. So I'm gonna do import NLTK. I'm gonna try to run it. So this hadn't worked before. Okay. Just try something. So I'm going to do Python import NLTK. So I just want to confirm that, yeah, that works. So that's not the problem. So that works. Are you guys also having this error with the URL open? But it was working before, right? I think when we installed something, it broke this. All right, let me try from URL lib request import URL. That works. All right, so let's see if we get it back. All right, go back to the script then. Just here, let's put back NLTK. NLTK also here. Not request. Let's try. All right, so that worked now. Good. All right, so we are trying then to remove text, right? So what do we see here? Let's go back to the script. So now I'm able to download data, read the data, and print it out. And you can see now that this URL request actually is useful, right? What do you guys notice about this text? Let's run it again. It's missing the tags. You guys see that? So before we were getting it with the tags themselves, but now does it have tags? Or it does have tags? I guess it does have tags. All right, so it still hasn't. I was confused. All right, so then we need to take them out. Then. All right, so we're going to remove the tags. That's even better. All right, so let's try from NLTK clean HTML. Let's see if we can remove the tags somehow. So I'm going to do here, possibly down here. I'm not going to print it anymore, I guess. Well, here then. I'm going to print right there. And I'm going to say raw equals NLTK dot clean underscore HTML. And the input to it will be, let's change the name over here and let's call it HTML. Just to kind of emphasize that this still has the tags. You can print out the length here. All right, and now in here, we're going to clean it up. And hopefully, we're still going to have some stuff in it, but not the HTML tags, etc. Let's go ahead and try that one. All right, so it's saying to remove HTML, use Beautiful Soup's get text function. All right, so So it's recommending that now. So let's go ahead. Import beautiful soup. Beautiful soup. And then I said clean text. So let's just comment this one out. Raw. Text. I think it was get text maybe. Go ahead and try it. So it was actually get text. No module name, beautiful soup. BS4. Just BS4. All lowercase. All right, let's try that. It has no attribute get text. All right, let's try this one. Let's do from BS4 import beautiful soup. And let's do that. As BS. And then this should be correct. This is correct. This is correct. Let's just get rid of this. And then now, let's do soup. BS. HTML, comma. We may need to do something else, but let LXML. And then now it would be, I guess, soup dot get text like that. All right, and then let's also do pip install LXML. All right, that worked. It's got a nice little database for cleaning things up. And then now let's try if it works. Yeah, it should probably be from. One more time. It worked. All right, so let me go over what I did. So we're trying to clean things up, right? So we're doing basically this is a lot of the work of data science, right? Just getting the data. Remember the steps. Collecting the data. So you can see all I'm doing right now is collecting the data. We've started to clean it up by trying to remove the HTML tags. Then we're gonna keep filtering it and cleaning it, and then eventually convert it into the vector space model, which means we're gonna make it into vectors. And then once we have that, we're gonna make it into tensors. And then once we have that, we have labels, etc. We can do supervised, and without labels, we can do unsupervised learning. All right, so let's think about this. So NLTK, actually, I didn't use. Instead, I just went with BS4. Thanks. So from BS4, we imported beautiful soup and we called it BS, right? We also do the URL lib request, import URL open. So we have some kind of URL. So my website, but it can be anything. You can grab, let's say we do lsu.edu, university, and we're going to download that one, check the length. Then we create a soup object where we say, obviously, the module is BS, beautiful soup. The thing that we're modifying is HTML that contains the data. LXML is basically, you know, think of it as a database of how to clean things up that can be updated, right? It's a practical solution to constantly update so that you can get better cleaning. Filtering and cleaning your data is going to be pretty tough. It's a big challenge. Imagine this is just one page, then we would have to automate this for possibly hundreds of thousands of web pages, right? And then soup then just applies the function get text that was recommended by the system itself. And then we obtain raw, and then we just print it out. So you can see we just have our text in there. So let's go ahead and run it one more time. And you can see it works because it's mostly text now. You see that? It's got only like human readable, natural language, basically, text for our purposes. Is this clear for everyone, guys? Yep. All right, great. So this is what we're going to be doing, as I said, for a while, just getting data. Now you have, now I can say to you, for instance, with this, go build a data set. I want you to build a data set, but only about like, you know, Toyotas. Only about Toyota. Nothing more. Find all the websites. So you have to build a crawler, go out on the internet, get everything that people are saying about Toyota. But then you might say, well, if we just get website data, that's not very good because that's just probably people that already are trying to sell you Toyotas. What about what people think about them, right? So then where do you go? You have to go to the social media sites, correct? So where are you going to go? You have to go to the RSS feeds, blogs, bulletin boards, and obviously Twitter, Facebook, those kinds of places. Do you guys see that? And that is basically that's a huge industry, right? So it's a lot of people doing this. Just think about this one statistic that should blow your mind, right? Boeing, the Boeing Corporation, that big company that makes, the big airplanes, they make military stuff, they make space related things, roughly should represent, at least at some point in its history, maybe that has gone down a little now, but it represented something like 5 to 10% of the GDP of the United States. Think about that, right? In terms of aggregated value, that's huge. Now think about this. Google, the company that you all know, right, that doesn't make anything. Google doesn't really make anything. They make a lot of experimental things, but their main business is the search engine. Has so much cash. I'm not even talking about assets. I'm talking about cash on hand that they could buy Boeing twice. They could literally just show up with trucks full of cash at Boeing and buy them twice. And they make all of that just with this stuff. Do you guys see that? Do you see how big a business that is? Just to give you some context, look it up. So this is certainly a few years ago I looked this up, so it might have changed a little, but they probably now just can buy it 3 times, if anything. That's what it wouldn't surprise me. Anyway, so the point is that, it's certainly a huge business, because if I say, go find out something interesting, some insights about Toyota, that could translate into, higher sales, right? Higher sales, you advertise to people, you know how there's, privacy basically doesn't exist on the web, and they're using all that information to advertise to you. So anyway, so this is the idea, and this is what we're trying to do now, collect data from social media, okay? So today we've started with this idea of, we've got some website, we process the data over here. Now all we have here is natural language data, right? This, you can see it's all information, written in natural language. We use Beautiful Soup because Beautiful Soup basically knows what we want, and they've provided a very nice tool to actually clean it up for us really nicely. Okay, got it? Now, but that's certainly not all of it. There's still some, you can see there's, first of all, there's a lot of enters in here. Do you guys see that? There's a lot of them because the spacing is all off basically. So we can still do a little bit more filtering, all right? And that will be kind of our goal now, all right? So basically at this point, we've collected data, all right? We're at that stage. Now comes the filtering part. So I'm going to go ahead back to the script. And in the pipeline, let's call this one, get the data. So we're going to say get the data. And then now the next part is in the pipeline, filter the data. Filters, basically. And that just means we're going to try to filter out a lot of things that we don't want, which I will not do all of these because that's actually going to be part of your homework. Every website that you go to, it's going to have its own challenges, right? Every website you visit will have its own challenges. And so, oops. Okay. So let's see what else we can do. So we've got the data. There's something called a tokenizer, and that's certainly something that you might want to do at some point, tokenizing your data, right? So how does that work? So let's try to do that. Since we have NLTK, let's see. Let's do tokens. So let's do tokens. Tokens is basically, we would take all the words in a sentence and make them into and take that string, which is a sentence separated by spaces, and convert it into a list of words, right? So that's called tokenizing. So we would do NLTK dot word underscore tokenize. And then what do we tokenize? We tokenize some kind of a string. So let's hear the cat is sleeping. Just an example. Okay. So then we would try to print tokens. This will probably give us an error because it'll want a database. But let's go ahead and try it. Oh, yeah. I have a little typo down here. I missed a double quote. Right, so now, there it is. Do you guys see that? I was able to take, did you guys understand? I was able to take, now, do I need this right away? No, but it'll be something that you need to do at some point, right? Because you need the words possibly for some of your filtering. So if you notice, I took what was a string, right? A string variable, the cat is sleeping. I tokenized it, and now I have a list of the 4 words. Does this make sense? Any questions so far? All right, so it seems to be making sense. So this should be pretty relaxed, actually. It should be a relaxed day today, just going through this. All right, fun. I think it's fun. All right, so we've got we know how to tokenize. So you know how to do that. Just keep that in mind. Let's see what else. There's a lot of things. NLTK, I strongly recommend that. There's the book. This is my book from a long time ago. It's probably much, I don't know what edition they're up to now. But it's called Natural Language Processing with Python. It's a nice read. I mean, if you really have an interest in natural language processing, this is the book to get. Just work through it. You'll have a lot of fun. Okay. I'm only using a little bit of it, but there's so much. There's so much out there. So anyway, let's see, what else do we want to do? And then later on, we'll do RSS feeds, but we're not going to do that right away. Okay, so all right, so what else do I want to do? I probably, now the filtering comes in, right? That's what we were doing. So we want to filter things. So what do I mean by filtering? So actually, let me add another one here. I'm gonna label this tokenize so that you have it and you know how to use it if you have a need for it. But here, let's add another one, and it's going to be the standard, simplest possible filter that you can have. Okay, and the simplest filter that you can use is the replace filter in Python. Okay, so what does that mean? It means, for instance, that we have, raw one, and let's say raw one is the dog is sleeping. Okay, and so now I'm going to create raw 2, which is basically raw 1 dot replace, and you're going to replace, let's say, dog with something else. So let's say bird. You guys see that? And so now let's print raw 1. All right, let's go ahead and do that. So it didn't do it, huh? Oh, so we want to print out raw 2. And there it is. The bird is sleeping. You guys see that? So that filter can be applied to a lot of things. We can, for instance, apply it to that kind of annoying enter, right? We can also do that. So let's go back. Now that we know how to use it, here when we print raw, we have all those enters in there. So now let's do raw, the new line character, which is expressed like that, although we can't see it. And we're going to change that in the string to nothing. So that way we get rid of it. And then we're going to have text that's a lot closer, and that's useful for your processing. Usually you want to do this. So now let's see. You guys notice the difference? Huh? It got rid of the new line character, right? So everything is closer together now. It's starting to be better. In terms of processing, this would be a little bit better. See, now basically it took the entire website, and in terms of the natural language text or the semantic content, it kind of just summarized it, basically, if you want to say that, to this amount of data. Now it's more readable to a human, and now we can do more processing. Now let's tokenize. So I'm going to take all that. Remember, this is still just a string. I'm going to make it into a list of words. All right, so then let me just make sure here that everything's working. How do let me a sec. Still recording, so I'm gonna, yeah, all right, there we go. Okay, so we're gonna go back to the text, and now we're gonna just tokenize the whole thing. Oh yeah, good. You want me? I have to go to the text to understand what you're asking. Give me a second. Yeah, what's your question?
So some of them, because the new line disappears, a word goes together with another word into one word.
You mean like here, maybe?
Yeah, there's quite a few places.
Really? Where else?
Feedback, accessibility, community how right there.
Mm-hmm.
But if you do a space instead of, like, replace the new line character with a space, then it doesn't. The two words together.
Got it. So then what you're suggesting is let's just add a one space.
Yep.
All right, let's do that. What do you think now? Did it do it? What you wanted? All right, good. So yeah, exactly. Exactly what he did is exactly what you have to, right? So you have to, many filters in here. And this, you know, the problems you encounter here usually generalize, but there's every page can be a little bit its own problem. So you have to look at things, right? You might in some here, this website doesn't really have anything, but some will have Unicodes, some will have like hex values in there, right? So we'll play with a couple, once we've built this, we'll play with a couple of websites just to get a better feel for it, okay? So let's go ahead and go back to the script. I think we were going to tokenize it. So we would tokenize raw 2, right? So then again, we do tokens. NLTK dot word underscore tokenize. And then here we're going to say, you know, no, oh, yeah, now it's going to be raw 2. Right. And then we're going to try to print tokens. Go ahead and do that. And you can see now the entire text has been made into a list. Why is this useful? Because now you can iterate through it, right? In a list, you can look for things, you know, so it starts to help us out a little bit more. But there's still an order, right? If you read it, all rights reserved. If you look at this, all rights reserved, you can still see it's still in the order that you would find it. Okay. All right, so let's see what else we want to do. So we took that text. So now let's go back to the script. And now comes the data science, right? Now comes the data science. So what I mean by that is, you know, data science sometimes doesn't necessarily have to be machine learning, right? It's a little bit broader than that. And it just means visualizing the data, statistics about the data, whatever, right? So here, I'm just going to give you an example. So we took the text, we removed the new line characters, we tokenized it, we have it in tokens. now we're going to use from NLTK another nice little function, library if you want to call it that, called the frequency distribution. So in data science, you like that a lot, right? People are obsessed with finding the frequency of things. They want to take everything, put it in categories, and get the count, right? So that, just remember that. So then you're going to do from NLTK import frequency distribution, like that. Right, so then now let's actually run it, make sure we don't have to find out what okay, it worked just fine. So now we're gonna go back, scroll all the way down. We have our token. So this part, let's call it the data science or data analysis, right? So we're analyzing our data in here. So we're going to create an object fdist1 and we call frequency distribution, right? So we call frequency distribution and we plug into it the tokens that we just calculate from our raw data. Okay, guys? And then after that, we are going to plot it. So we're going to create a little graph, kind of like what we did with linear when we were doing the linear regression examples. So I'm going to do f distance 1 dot plot. And then we're going to pick first parameters like the first 50 most frequent words, and you can play around with how it does the percentage aggregation. So in this case, let's just say cumulative. Right, and then you guys can explore this. So let's try it. So this, unfortunately, this function depends on matplotlib, and matplotlib is always a challenge when you're installing it on Anaconda. So let's see if it gives us an error. If not, we'll have to probably install that. Or we don't. So we already had it apparently. So did you guys see it? I don't know what happened. Here. Probably I can do this. All right, perfect. About 50 words. These are the most frequent words in that text, and it's basically showing cumulative counts of them, of the percentage that they represent. Does this make sense? And again, you can do multiple types of analysis. So here the analysis is not so important. I just want to show you the pipeline of it, and then just change to histograms or whatever it is that you want to do. Now, if you notice, LSU, it was lsu.edu, so obviously LSU was everywhere. If you notice, the is here, and the is usually one of the most frequent words in English. So, but if you notice, what I want here, I'm not so concerned about the line, the blue line in this example. I'm more concerned about the words that appear down here. So for your homework assignment, I'm going to ask you that everything that you do, the 5 websites that you collect, the 5 RSS feeds, the 5 Twitter collections, all of them should end up with one of these. Does this make sense? They should all have that. Why? Because that will be a very quick way for me to know that you've done a good job. If you notice, how will I grade this? I will only look at this picture. I'm going to look at these words. Those words need to make semantic sense. They need to tell me a story really quickly. You guys see that? If you don't do a good job filtering, what's going to happen? A lot of it will be ampersands, the, hexadecimal values, exclamation, periods that tell me absolutely nothing about what's going on. Do you see that? So, I've had students that submit this homework and it's pure like hexadecimal values here or something. I can't make sense of what that is, right? I'm looking, remember, I'm looking, data science is about finding some insight, right? Some knowledge, reading through the data. So I have to be able to read these words and know what this is about. So for instance, I'll give you, I think we ran this class the last time around this time, and it was the election, right? So students then could easily tell me what the news cycle was saying, right? So it was election this, the candidates, all that. So here in this one, because it's LSU's, I can see Louisiana State, campus, academic, blah, 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 right? So it's some kind of a website of a university. We'll do another example. So now we have this one. So let's switch over to another website. So give me a website that you guys think would be interesting to look at. NASA. Is it nasa.gov? Is it gov? Or is it, yeah, it's gov, right? All right, so let's see nasa.com, right? So let's try that one. Gov, yeah. All right. Good. So let's try nasa.gov. Oh. See here, I don't know what happened. Huh? There's nothing, right? There's only the word NASA there. How come? So this is what I was saying, just because it works for one, it's not necessarily going to work for everything. Is there text in their website? Yeah. It's interesting, right? There's a lot here. Oh, really? It's just like a widget or something inserted in there? Yeah. Okay. So as you can see, that's a problem, right? So that if you're trying to crawl NASA as a data scientist, now you have yet another problem. All right. So obviously when you pick your homework, don't do it on this. Yeah. So let's let's try another one. SpaceX. Let's try SpaceX. Maybe they have a lot. All right, so let's do SpaceX. As I said, at the end of the day, that picture needs to tell the story. So I think it's SpaceX. Let's try that. All right, see, there's some words in there. Good. Do they tell a story? Falcon, Dragon, Heavy Human, Shop, Mission, Civilian Mission, NASA, astronauts. Yeah, so at least, it tells a little bit, right? I can tell it's the index page. This is okay. Okay, let's try the Wall Street Journal. Let's see what they have. And I'll just do one more. But you get the idea, right? So it should be pretty easy. So let's try the Wall Street Journal, which should have a lot of text. Okay. All right. Oh, that didn't work. Yeah, so that one's probably not letting us do this. Some websites don't want to be crawled or whatever because they don't want their stories to appear in another website, you know what I mean? So that's a possibility. Let's do CNN. Let's see what they do. CNN. Oh, there's a lot more here. What are they talking about? Biden, I see there, political, Tokyo something. Yeah, so that's kind of this is basically the idea. Okay, guys, that it's when you read, this is okay. As far as I would still like you to filter out things like this plus, the and, words that don't really contribute that much, but that's part of it. And certainly if you find a website that has a lot of, the thing is Beautiful Soup is now doing a really good job of filtering. That's really what's happening here. But this is the idea. That's the homework. This is for only HTML. Is this clear? All right, great. So you will have, so I'll create a document. It'll be due next week. And I'll just say, find 5 websites and basically perform, let's call this data analysis. Okay, and you can take a look at the data. All right, so that's good. All right, so we covered the frequency distribution plots. Beautiful Soup is covered. All right, so we are ready now to switch over to the RSS feed. All right, so those are a little bit different, but it's another source of data. And then after that, we will talk a little bit about Twitter. So let's close this one out. Now let's go back to the process. So the pipeline currently is, we get the data, right? So this was data for URLs. No, websites, let's say actually. Website. Now we still want to get the data, but this time it's going to be we're going to get data from RSS feeds. Get data, and we're going to say RSS feeds. Right. Then after that, we know how to tokenize. We filter, right? So you will filter. You do some data analysis of it. And then at some point, after you would do the data analysis, we still want to do machine learning, which means we're going to need, the X data, the features, and the Y data, the labels. So that's going to be, usually I just call it the vector space model. What I mean by that is taking the data and converting it into basically a CSV, of rows and columns, okay? Usually the rows, they're going to be either what? Tweets, they're going to be an RSS feed line, or they're going to be sentences in something that's longer, like a document or a website. Right? And then now the features are the challenge. What are we going to do with the features? So we're going to go back to that basic idea of the bag of words approach that we had thought about. So I'll do an exercise of that today. All right, so for this example then, let's do, I don't think we need to install anything. So let's just do an RSS feed. All right, so let's do here, I'm going to go up. I'm going to go up and new library. I'm going to say import feed parser. Okay, so let's try this one, see if it works. So I'm going to do Control X. Hi, I'm going to run the script. Okay, doesn't know feed parser. Let's do pip install. Okay, took that. Now I'm going to run it again. I'm going to disable that graph also, since I don't want to see it every time I run this script. So Okay. So now we can go up here. We have the feed parser and oops. In here, we're going to read the feeds. Okay, so I'm going to go over here. I'm going to now this you need to find the appropriate URLs for RSS. So instead of URL, actually, I'm going to call it RSS. Okay, and now you need to find these. So I have an example here that I prepared. And it's going to be actually from Purdue.edu. And then they have a newsroom RSS. All right, RSS event. And then we're going to say event news.xml. Okay, oops, remove that double quote from here. So that should be an example of an RSS feed. Now we want to proceed to make contact with it. So I'm going to create a variable D. I'm going to call feed parser dot parse, and then I'm going to specify in there RSS. Make sense? So now the question is, will we have access to it? So let's try it. So I'm going to run script. All right, good. So no errors. So that's a good thing. So now let's go ahead and finish it up. So in here now we have the feed parser and we parsed it. Now we can print out some information about this. So let's do print. And let's see. So the D object is basically it's like a two-dimensional list, a list of lists. So first we specify the feed, and then each feed should have parts, like it should have maybe a title, a description, a link, etc. So let's take a look. So actually let's actually print length of D, and let's just specify entries. Let's just see entries. Okay. And actually, for this to work, probably should have moved this down. I guess I'm going to comment it out then. Comment this out. Comment that out. All right, so that should work. $49, yeah, 49 entries, right? So let's go back to the script. You also don't need to print this anymore. Or this for that matter. Right, just 49. So that tells us that there's data there in the RSS feeds. Now let's try and go ahead and print some information about each one of these. So let's do in here, let's do print D feed title. Okay, so let's try that one. Purdue University event news, right? So we're in the right place, obviously. So now let's see if we can't print a few of these. So let's go over here. And we're going to need some kind of a loop. So I'm going to do for post in d dot entries 1, 2, 3, 4 print post dot. Okay, so now hopefully this will print out some information about the RSS feeds. And there they are. You guys see that? So these are your 49 RSS feeds. So Purdue University News, Purdue University Department of Theater to present Fefu and Her Friends by Maria Fornes, former NASA astronaut and Purdue alumnus to speak at Purdue Honors College. Exciting. Delita Martin to present solo exhibition in Ringgold Gallery. Something about the police. Investigative journalist John Carreyrou to speak at Purdue. And then convocations, music group, choir, dedications, convocations. Anyway, lots of information there, right? So you can see from the RSS feed. So now if you're interested in, cars or video games or whatever it is, sports, you can collect individual RSS feeds automatically. You can automate the process and then build some kind of a machine learning application. Does this make sense, guys? Remember the term project also? Remember I said there's a part A and a part B? You guys remember that? What is part A? Looking at the flight data, right? Remember? ADS-B exchange. That's just a lot of data that up there, but remember, that's all sensor data. So it really doesn't have that much text or anything like that, but it has a lot of it. There's a lot of data without a doubt. So that's why I do part A and part B. I want you to play with a lot of data, right? And then also I want you to play with data like this, because here the problem is you're going to have to annotate this somehow. So you will not be able to have a lot of data for this one. So for part B is little data, for part A is a lot. Does it make sense? But this is what I want you to do for part B is collect some data like this, pretty much like this homework assignment. Collect data like this, and then convert it into vectors, the vector space model. Find some labels, because it should be a supervised learning problem. For instance, positive and negative. So I could easily right now tell you, and it could be a project, that you're going to look at all the Purdue's RSS feeds for the last year, however many years are still available. And then you're going to say, you're going to classify the RSS feeds by interest. So for instance, you're going to say like, these feeds I would want to read, these feeds I don't care about. Do you see that? Or it could be positive and negative feeds, or it could be feeds about speakers, that kind of thing. Is this clear? That would be the problem for part B. Some kind of a simple classifier, but you have to build the data set from this. From a very unstructured source, you have to build a data set. Now, the limit will be that you can't create a data set of many samples. It'll be 1,000 to 2,000 at most, right? And so part B is that. Part A is the ADS-B data, where you have hundreds of thousands of records. The data is already structured in JSON, and so you just have to do also an analysis. Is that clear, guys? Are there any questions about the project? Part A, part B, is it clear now? Yeah, so part A is the ADS-B, right? Data, flight data. There you have structured data in JSON and a lot of it. I usually do this because I want you to play with both big data and small data, right? So the advantage there is you have a lot of data, but you can't really So you can play with it. It's already structured. But I also want you to take data that doesn't exist, basically from the internet somehow. So I want you to collect your own data. That's where part B comes in. You see that? I'm not telling you what data to get. I'm only showing you these tools: Twitter, RSS feeds, and HTML. Get your data from there. Huh? Yes, part B is use your own data. Yes. Where you have to collect your own data. Exactly. Good point. Part A, ADSB exchange. The website is there, the JSONs are there, download. Convert it into vector space model. It's already in JSON. It should be pretty straightforward. Here, part B is, as you said, collect your own data. Find your own problem, whatever you want. It doesn't matter to me if it's HTML, RSS, Twitter, whatever. Collect it. My experience is to make that data into a supervised learning problem. The challenge that you're going to face is that your data set will be very small, because you'll learn the difficult task of creating a data set. You see that? That's my whole objective. Creating a data set is very difficult. You know, remember the whole garbage in, garbage out? If you do that whole process incorrectly, it doesn't matter that you're using state-of-the-art PyTorch deep learning. Garbage in, garbage out. And so that's why it's important to do this one, part B, and part A also, because it brings in the challenges of so much data and what do you do with it. Is this clear, guys? Yeah? All right, great. So this is a good stopping point with RSS feeds. Let's take a 10-minute break. So let me stop the video here.